I'm going to have Gael give his presentation, and I'm really, really curious about the robot and your journey. So I'm going to be asking a few questions.
Very nice.
Fantastic.
I'm here for that, actually.
Great. I also would second what our friend said here. It's much better for the people that are presenting where people are closer up front. So maybe in between, you guys can make an effort and just get to the front.
Vamos a hacer una dinámica que consiste en levantarse, los que estéis atrás, que os vengáis para aquí, para crear calor humano.
Gracias.
Mucho mejor. Estamos en Galicia, estamos cerca del invierno, llueve mucho, hay mucha humedad, todos juntos. Es primera hora, todavía no hemos sudado lo suficiente, sé que estamos bien. Y como primera dinámica también para despertar y para que...
Yeah, it's nicer because we can make a campfire.
Yeah.
Start to get warmer.
Podemos hacer un fuego aquí como si fuera un campamento. Ya se fue, los responsables de la Ciudad de la Cultura ya se fueron, así que no hay problema, it's no problem. Muchas gracias por el esfuerzo, de verdad. Esto a nivel audiovisual, para la gente que está haciendo vídeo y foto, es maravilloso. Parece que somos 80.000. Vale, thank you.
Fantastical, thank you so much. Okay, now, so Gael, what would you consider yourself? Are you an engineer, a designer, an innovator, a maker, all of the above? Can you just...
So I'm a sculptor designer. I create objects for commercials. So basically what I do, there's orders, my clients, they ask me to create an object, and then I have to think of how to design it and how to propose that idea to my client. So it's very various. It can be for Chanel, it can be for Dior, for different brands, making some gold powder turning with the system with the turbine, or creating a sculpting something like a logo that is going to be on display someplace. So it's every time it's a request from the client, and I have to really think of how this is going to be built. Most of the time it's something that has never been built before, never been done before, so you have to find solutions every time. And so it's sculpting, designing, creating, making.
All of it? All of the
All
above?
of it at once, yes. And in fact, the project, we're going to talk about it, but the project Inmoov started like that.
So I'm really curious about how the project started. So most of your assignments are requested from a third party, are requested from a client, from a company, some sort of initiative. What about Inmoov? Was that also requested by somebody else, or were you the client here?
Yeah, so the beginning of the project, it started, one of my clients was making a commercial for a French car company, which creates cars for handicapped people. And they asked me, for that commercial, they wanted to have a prosthetic hand that would look very futuristic-like. So at the time we were in 2011, and I thought, what is going to be futuristic to make a prosthetic? And I was working already for a long time with the 3D printers company. They would print things for me. And I just had bought for my workshop a little 3D printer. And I thought, what about if I would just 3D print that prosthetic? Would that be something that would look like it's something from the future? And I went to search on the internet to see if there was already 3D printed prosthetics. And at the time, there was nothing. And I thought, that's it. That's really something that is going to be futuristic-like. Proposed it to the client. The commercial was too expensive. It just didn't go on. But anyway, I really love hands. I've been sculpting hands since I'm a kid. I've been putting the hands of my brother and sisters into plaster to mold them. And yeah, hands is really something that I really like. So I decided to make that prosthetic anyway, designed it, added some motors to make it move, and I think we can go further with the video. Okay, this is not going. Yeah?
Yeah.
Let me try some more. I'm trying, I'm trying. So this is a list of clients. Yeah. So this is the hand. And so I decided to design the hand anyway, added some motors into it. And then once it was designed, it was working with Arduino boards, and I could have kept it in my workshop, but I decided to share it on the internet. So like this, it became open source. Everybody could use it really as a prosthetic hand. So that's how the project started, just with a hand.
That's a great story, because usually projects that turn out to be really big start, as was mentioned here earlier, start as something really small. So maybe you have to thank the clients who initially asked for the hand. But now this has turned into something much bigger than a prop for a commercial, right?
Yeah.
So this has been a journey. Can I ask one? So when did it start? How many years have you been in this? And then two, I'm sure it's the intention of the project has completely changed. So what is currently the intention of keep working on Inmoov and keep improving it?
Yeah, so putting the hand on the internet as open source project really started up a whole process in the community of makers. They took the hand, started to modify it to use it as prosthetic for other people. But then at the same time, I kept on designing other parts, biceps, shoulder, torso. Somehow, why making a robot? Some people, they ask me, you know, why a robot? Why a humanoid robot? I don't really have an answer. The only answer I could give is when I was a kid, I was building a little wood person, and I was really hoping that someday it would start to move, you know, like a Pinocchio. And somehow it's a huge Pinocchio that I'm building, you know, and I feel like Geppetto with my beard. So, and then giving the possibilities of other people to reproduce the hand, to reproduce the parts, creates a community around the project, and it allows people to be all Pinocchios or all Geppettos more likely.
How long has the journey been going on?
The journey, it started in 2011, so now it's been 7 years. 7 years of designing, modifying the parts, making it better, adding the software, adding all kinds of things into the robot to make it more living stuff, living Pinocchio.
Do you know how many of these robots are out there in the world? Or I mean, some of pieces, parts, torsos, but if you include all of them?
We estimate about 1,000 copies of the robot in the world. This is an estimation that is based on the boards inside the robot. It's using Arduino boards, so it's microcontrollers that are open source. You can see it here on the bottom right. And this board, on it we have created, with a Dutch team, we have created a shield that is plugged on it, and it allows to control the robot, but also to connect everything together on the robot. So we are selling those boards on the website, and because every time we sell a pair of those boards, it means it's possibly somebody building the robot. So that's why we estimate about 1,000. But there's a lot of people that are building the robot with other things than those boards. You can create your own boards. You can use softwares from a third party. So there's many clones, many copies, and the hands, I don't even count. The hand is crazy. You know, there's some associations now. They print the hand for kids in India that are missing limbs. So it's really tremendously a lot. There's no way of counting.
Yeah. It must be really tremendously rewarding to understand or discover some of the cases, like the one that you mentioned, providing a kid that doesn't have a hand, a journey or an experience for them to be able to empower themselves through this technology. Can you maybe share some of the most interesting uses that you have discovered, or the people that have applied this technology and this platform in different parts of the world?
Yeah, there has been some projects that are very interesting. For the hand, for example, I think there's one group of students in Italy, also in Russia. They have been using the hand to teach children how to do sign languages. So they use the same hand, but they transformed it so the fingers can move a little bit differently, but it's based on the same design at first. And then from then on, they teach the children how to make the sign language. And it's very interesting because it's like with an object, you transform it into something else. It gives another purpose to the object. It's not just a prosthetic. And then we have seen some students also that started a project where they are using the robot in a hospital. So basically the idea, the robot is outside the room of a kid. The kid is in a chamber that is sterilized. He doesn't have access to the outside for weeks or months. But then he has a remote control with a visual system, so he can see through the eyes of the robot, and with the remote control he's able to move the robot. So this was a project that started, but it didn't go on. It kind of stopped. But anyway, the idea is great. I mean, I've been trying it with the robot, having the robot in Holland, in an exposition, and I was in France, and I was able to see through the eyes of the robot and see the robot showing his hands or shaking people's hands. It's just amazing, you know. And to imagine that a kid could do this in his hospital room, have access to the outside, using a robot. You know, it's not just a platform on two wheels that is driving around. It's a real humanoid robot that is activating. So this is thrilling. Yeah.
I guess it's every kid's dream come true of actually building a robot yourself and actually interacting with the robot and doing things that are beyond what you can do as a person. Or
in that case, they don't build it themselves. We provide the robot and they have access.
Okay.
But yeah, there's also some kids building the robot. We're going to see it a little further. We can see here on the pictures there's the robot in a certain stage when I've been building it with wheels so it could drive around. And let's see if I can go further. This is on the website, all the parts, all the pieces that are put together so people can follow the tutorials how to build a robot. Because there's many projects where they say it's open source. They start the project saying it's open source, but then when you want to find the files, when you want to have access of tutorials, explanation and all of that, there's just about nothing. So making it available as open source, it's really important to propose tutorials, to propose explanations for people to be able to follow the project.
I mean, to me, that is one of the most important and powerful things about the Maker movement. This idea of very smart, creative engineers, designers, making something unique, making something that pushes the limits of technology, pushes the limits of what we can do, but instead of putting it in a very private organization where it's considered IP and only a few people have access to it, this idea of putting it out into the world and letting anybody interact with it actually is a way of pushing the technology in a much faster way. And not just pushing the technology in a faster way, but finding new ways that you would never have imagined that this technology could be used. Can you talk a little bit about the power of an open source project and then the contributions or maybe the requirements or the responsibilities of the community that is collaborating, that is contributing to the project?
Yeah. Actually, it's really important to have a community. When you make an open source project, wider the community is, more protected you are. In the sense that my project is, I say open source, but somehow it's tricky. It's not totally open source. There's a license on it that is protected as a designer, so it's non-commercial. That means you're going to be able to use it, but you can't make money with it. So having a huge community around that is working on the project, that is developing parts and things like this, allows to protect the project. Because then you get, you might get some lawyers that are 3D printing the hand, or might get some jurists that are also building the robot. And those people, they also want to protect the project. So it's very important to wide up at maximum level the project. Now, the contribution also of the community is important because they will bring some new ideas. new modeling, prototyping some other things. For example, for the robot, I'm working on the legs, but I'm still not ready. But there's already some people that have been creating some legs that are mechanized. They are not properly walking, but it's already some steps, you know. It's and that's really amazing. It creates how would I say, something that really drives up people.
Yeah.
Do you see?
Some people encourage and stimulate and inspire other people, and it becomes like a competitive thing.
Exactly. And in fact, it's amazing, because when I started the project, I never thought the robot would be able someday to walk. But now I see the possibility, you know, if it's not me, it's going to be somebody else that is going to do it anyway. And then I'm going to be able to to use those legs from that person or from those students. I'm going to be able to use it on my robot, and the robot is going to walk. At some point, it's going to happen.
I really believe in this idea that you can have a small group of very creative or very smart designers and engineers, but it doesn't matter how smart or creative they are, they will never be able to do more than a distributed community of creative individuals that have different experiences or in different parts of the world and have different motivations of why they want to develop things.
Yeah.
But what about from a more formal perspective? So today, maybe even 20 years ago, the only way that you could get access to this type of technology or learn about this stuff was at a university, a place like at MIT or many other technical universities. But today, a lot of that learning, a lot of those experiences are not happening in a university campus. They're happening in garages and in rooms and in all kinds of different places. But maybe you can talk a little bit about how the formal education institutions, like the universities, have been using the robot, and what is the place of a project like this in formal education?
It's really used a lot in schools. Yeah. There's many teachers. They have technical projects, you know, and there they have the ability to take just a hand and propose to build the hand with the students. And the sound is a bit strange there, no? Isn't it? It's like they're going to build the hands, but with all the students, they're going to build one finger. Each one is going to build a finger, and then they're going to put the finger on the hand, and then they are going to be programming. This brings the idea of each one is doing something, but at some point you work together. When you want to program the hand, it's everybody together. And it's exactly the same idea with the robot. Everybody's doing the robot in his home, in his garage, as a team in school, but then at some point you need the AI, you need the software to make it work. You need to have something in the community to participate, to make it completely work. And I think more and more in the education, this is something that is going to come up, because education is based on something where we have something that is established. The students, they have to learn this through the year. I think in the future, students are going to be able to grab things what interests them most on the internet or different platform, or maybe with a group of teachers or something like this. And the access to the data, to the knowledge, is coming from such a different way than before. It's evolving very fast. And I'm not sure, for example, I'm talking about France. I'm not sure the French education is really seeing what is happening and how fast it's going. I think it's really important to realize that there's just so much you can learn from the internet. Of course, you can learn terrible stuff, you know, and that's where the education should be, to drive those students to find the right things to learn, to discover on the internet. But there's so much things that can interest them and show them the path of their life, their job, the future.
Is there a different type of relationship with formal education institutions? I think you said there's 98 or 100 different universities that are formally using the robot. Do they interact directly with you, or do they just grab the project in an open source way and do it on their own? Is there a formal relationship between?
Yeah, it's funny to see that the education in there's 98 universities that are building the robot. Known, so we saw them on the internet actively or something like that. Those universities, most of the time, they will build the robot and they work as a little community, but they rarely share information. It's the people that are sharing, it's mostly the people that are working on the robot in their garage. Those people, they feel like they should contribute back to the project. And it's funny to see that it's something similar than recycling. Big companies, they can decide to recycle. Everybody in the company is going to recycle. But if the company is not recycling, nobody inside the company is going to decide to do recycling. When you're at home, it's a personal thing. It's a personal matter. You decide yourself, okay, there is a bottle, I'm going to recycle. Sharing on the internet, it's pretty much the same. It's like a personal feeling. Do you feel part of a community? Do you want to give back something because you have been able to use a free software or something like this? You're going to give back.
Excuse me.
I guess it's the difference between going to school because you have to, because your parents make you, or learning about something because you're passionate about it, just because you're very curious and you want to do it on your own.
Yeah, maybe it's something like this. Maybe the fact that it's more interesting because it's really something that touches you deeper inside. Maybe that's why.
What I really like about this project is that it has both a hardware and a software element to it. And when you combine those two, then you have some pretty amazing things happening. Can you talk a little bit about the software? I know there's machine learning happening, there's artificial intelligence, some of these very cutting-edge disruptive technologies. Can you share a little bit about that?
The software, maybe we can go further. Yeah, that's, sorry. I'm confused with the pictures. I think I will just go on with the pictures and...
Excuse me, Gael and Stiven, we have to finish.
Oh, we have to finish.
Maybe we have some questions, 1 or 2 questions.
Sure.
You can finish right now. And sorry.
I do have one last question, a quick
one.
Because we are in this is Maker Faire, and this is a fantastic project. I would love to get just your final words and what are your dreams and aspirations for the Maker movement?
Makers has always been there. I think we are all makers at different levels. You can be sewing, you can be knitting, you can be doing software, whatever. You're a maker somehow. And we've been talking a lot of makers lately because the industrial system has been developing consuming. Yeah. We have been buying things, buying some phones, not looking inside. But at the same time, some people were still looking into the elements that they were buying, still opening those things. And I think makers will always be there. And I think it's really important today to just give the possibilities to education, to people, to open things, not to close objects, not to close the devices that we buy. If you have a TV, it's broken, let's open it and see what's inside. Maybe you find the solution and you help a whole community.
Fantastic.
Yeah.
Thank you.
Thank you very much.
Thank you. We have time for one question.
Just one now.
If you want.
Make it a good one.
Yeah.
Okay, this guy. I don't know you.
Okay, thank you a lot, both, for all your interesting ideas. I would like to ask you, because I guess you started with just a hand, but maybe you didn't imagine what it will become in the future. And I guess it's like a child for you now, this robot. So where do you see it maybe in 50 years' time? Like, what do you expect this project, where it will go, and what it will achieve? How do you imagine it?
I think I will be totally unbodied. My brain is going to be just a chip, and I will be inside the robot for 1,000 years. That's what it's going
Immortality
to be.
Then.
That's not really what I want, but it's what is going to happen. Yeah.
Okay. We have no more time. So thank you. Muchas gracias.
Thank you.
Gael Langevin y Stiven Kerestegian. Gracias. Y vamos a preparar rápidamente la siguiente mesa. Ah, perdón, excuse me. We have presents for you. This is our little robot. It's not like yours.
Thank you. Beautiful. Thank you.